Okay, so let's start with a quick review of what we were doing last week. Last week, the process we were going through was called solving systems of equations. And so what did that look like when we solved systems of equations?
Getting the x, solving for x and y. Getting both variables on different sides of the equation. Two equations on top of each other.
So, okay, it was two equations.
Finding a solution to the
Trying to find points.
something,
Trying to find points to plug in variable. Trying to find points to
a
plug in
solution
variable.
to a line.
Trying to find the word pair?
Okay, I get it.
That's the best one I've heard yet.
What?
The intersection.
Slope intercept point.
So, systems of equations were two equations. Both of them were lines. Right? An equation with two variables makes a line. And so we were finding where did the two lines intersect? Right? Do you remember that? Systems of equations. The point where they intersected, this was the solution. Because it's what they had in common. Okay, what else could happen? Our lines could be parallel, which was no solution. Or we could have had the same line,
Infinite solutions.
which is infinitely many solutions. You guys remember doing that? So we've got to put that in our memory bank. That's called solving systems of equations. Where you take two lines, you find where they meet. The point that where they meet is the solution. If they never meet, there's no solution. If they always meet, there's infinitely many solutions. We're going to take this idea and apply it to what we were working on yesterday. You guys were graphing inequalities. So what do you think we're going to be doing today if I'm going to marry those two ideas together? We're going to be solving systems
Graphing equalities.
of inequalities.
In other words, poetry.
Systems of inequalities. So this one has to do with kind of the same process we were doing yesterday, but where they overlap is not going to just be a single point anymore. Because what happens when we graph an inequality? Our answer is not just the line, it's the line and everything that's shaded, right? And then we're going to graph another line, and then we're going to shade everything on that side.
You're just going to have one.
And the solution is going to be where these lines overlap, where these inequalities overlap, which would be this section here that I'm coloring in yellow. You see where the red and the blue meet? That is your solution to your system of equations. Or sorry, to your system of inequalities. So ingrained to say system of equations. Okay, so I hope you're good at graphing.
Yay.
What are the solutions to the linear inequalities? So here's you another chance to learn how to graph a line. If you don't remember how to graph a line, because guess what? You're going to be graphing lines for the rest of your mathematical career.
My mathematical career, why don't I get paid?
I've been asking the same thing.
How much do you get paid?
What?
Not enough.
Not enough to do with you guys. Not enough.
Honestly, need to ask for a raise for real.
One of my classes said they were going to protest
Really?
until I got a raise. Yeah, they said they just weren't going to show up. I said, that sounds like a plan.
I heard how much.
I said, just don't do it on Monday or Tuesday next week, because I'm not going to be here. So I'd hate to miss that protest.
I hate how much you complain about it.
So if I had to graph the first one, y must be greater than x minus 2. That's in slope-intercept form. It's already in slope-intercept form. So I would use the y-intercept, which is negative 2, to plot a point. And then I would use the slope, which is the number in front of the x. I don't see a number, so there's an understood 1 in front of the x. So I can think of this as being 1 over 1 as my slope. So I can rise 1, run 1, rise 1, run 1, rise 1, run 1. Okay, now what do I do with this line?
You gotta make it dotted,
It is a dashed line because it's not
equal to.
equal to. So because there is no equal to sign, this should not be a solid line. It should be a dashed line. That tells me that the line is not part of the answer. All right, it still has arrows. And now, which side am I supposed to shade? Okay, this says y's must be greater than the line. So y's are greater than, that means I'm going to be shading above that y-intercept. Again, if you don't know for sure, you can always pick a point and plug it in. All right, but I'm going to be shading all of this area. All right. Obviously, when you shade it, don't make it so dark you can't see through it, because you're fixing to have to graph another line there. Right? So shade it in a way that you can still see the coordinate plane.
My graph looks so good. I need to go to art class.
Next, the next line. This is also currently in slope-intercept form. Y equals mx plus b. So I'm going to graph this line. The y-intercept is positive 1. So I go up on my graph to positive 1, put a point. The slope is negative 1,
Over 1.
which means I can go down 1 and right 1. Down 1, right 1, down 1, right 1. Could also go up and left. Okay, now what kind of line should this one be? Solid or dashed? Solid, because it has an equal to sign. So here I'm going to have a solid line.
That's the best line you can do in the world.
Hey, thanks. And look, I doubled down and made it worse going back over it. Okay? And now looking at the red line, this tells me that y's should be less than or equal to the line. So I'm going to be going beneath the y-intercept. So I'm going to shade in everything that's beneath in a second color. And so where is my actual solution? The actual solution is where those two colors overlap. Right? So I'm gonna put that in yellow, because on yours I think it'll be easier to see. It's hard for me to shade in solidly on this graph. Maybe hey, you know what? I got an idea.
Increase the diameter of the thing.
Hey, that was my idea. You stole my idea.
I just learned it from MS Paint when I have to do, when I get to Mr. Bill's class.
That's a little bit better.
It's a lot better. Less the effort too.
It is a lot less effort. All right, and I shouldn't have colored right here. This was a bad mistake. There we go. I fixed that.
Why are you doing that?
I'm doing what?
Hitting it. Why are you doing shut up. Why are you doing the yellow?
Just because I thought it'd be easier to see where they overlap.
That sounded like a little sister.
So-
She get mad at me.
You see, the blue shade gives the solution to the blue line. The red shade gives the solution to the red line. But the thing that makes both of them true at the same time is what you've got shaded in both. So what's a point that's over here shaded in both? Is the origin? Is 0, 0 shaded for both? So what does that mean? If I plug in 0, 0, it's going to make both true at the same time. This is a way you can kind of check your work. So if I plug in 0 here, is 0 greater than -2? Yes. Is 0 less than 0 plus 1? So you see how 0, 0 makes both inequalities true at the same time? That means it should be included in this shading. Because that's one of my solutions. One of many. Right? There are several points that would make both true at the same time. Okay, so if I have to graph this one, this says y must be greater than or equal to -x plus 2. So this is already in slope-intercept form. If I were to graph this, the y-intercept is +2. So I'll go to 2 and place a point. Then I'll use the slope, which is -1/1, to go down 1, right 1, down and right. Can also go up and left. Okay, what kind of line should I have here? It should be solid, because it has an equal to sign. That's not very good. Okay, I'll deal with it. That ain't great either. But. And now I have to decide which side to shade. So this says the y must be greater than or equal to. So I'm going to go above the y-intercept. So that's the solution to the first line. Now the second line is y must be less than -x minus 2.
Same.
So I'm going to go to -2, plot a point. The slope is -1/1, which means I'm going to go down 1, right 1, down 1, right 1. Could also go up and left, up and left, up and left. What kind of line will I have here?
A dotted line.
It's a dashed line.
Not dotted.
It's okay. I'll probably say dotted sometimes too. Yes, sir.
Well, quit again.
Wait, what happened? Why are you running out the fast?
He's gonna like here listen to the recording.
There's nobody there. I'm hearing things. Okay. And now which side should I shade?
The bottom of the Y. The bottom of the Y.
The door is broken.
The bottom.
Teachers can't open this door out here. So everybody's stuck pulling that door. So I'm the doorman today. I had to go open it. And I thought I heard it, and there was nobody there.
I wonder at the button.
Someone just went off.
The door is broken.
It's a ghost.
No.
Like our pass works, the thing on the outside works, and it beeps like it's going to open. And you pull it, but the lock doesn't release like it's supposed to.
Of course.
Except for Griggs. He's strong enough, he just broke that door. Okay, he's the only one I've seen open it today.
That's just Greg.
I didn't get to try. I'm scared the question I'll get locked out. Y is less than negative x minus 2.
Be the bottom of the y.
It's going to be beneath, less than. Y's must be less than.
No solution.
Why did I change it to green? I'm so dumb. So now I'm looking for where do these lines, where do these overlap? They don't overlap. So this would be no solution. Do you guys feel smarticle?
Yeah, it's just like the main.
Record. Y must be less than 2x. Is this in slope-intercept form? Yeah. What's the y-intercept? 0. Right? There's no number out here. So that means it crosses the y-axis at 0. And what's the slope?
2, 1.
2 over 1.
2 over 1.
So that means we could rise 2 and run 1, rise 2 and run 1. Could also go down 2, left 1. All right. And this line, is it going to be solid or dashed?
It's dash.
Should be a dashed line. And now which side should I shade? The y's should be less than the line. So the y values should be less than the line. So I'm going to shade beneath that line. Okay? Now the second one, what's different about this? There's no x. This is one of my special cases. There is no x. Well, you could add an x, but it would be a 0. It would be 0x. So this is the y-intercept. Remember yesterday I showed you the special cases on the board where y equals a number? When y equals a number, that's a horizontal line. It has a slope of 0 because there is no x, just a y. So I could go to where y is negative 3, which is right here. And then I'm going to draw a horizontal line there. Should it be solid or dashed? Should be a dashed line. I didn't do a very good job making my my graph here where you could see it. And now I need to shade which direction? Y's need to be greater than the line. Y's are greater than the line. That means I'm going to be shading above my line. And so where's my solution? Where's the points that they overlap? Oh, I'm having flashbacks to geometry class. Look at this right triangle.
Don't. Please don't. I'm begging you.
Honestly,
This is a 30, 60, 90 or 45, 45, 90. A squared plus B squared equals C squared.
That's a 45, 45,
That's like
90.
the only thing I
I'd rather do
remember.
geometry.
Yeah, that's a 45, 45, 90. Because that's a right angle. And that 90 is
That doesn't mean that the other two are both 45.
What?
Yeah, that is the angle of how it's like.
Wait, it's a 30, 30, 60 then.
This side is 1, 2, 3, 4, 5, 6, 7, 8. This says 1, 2, 3. It's almost a 45, 45, 90. Because this is 6 here and 1, 2, 7 here. So it's not either one. It's not 45, 45, 90 or 30, 60, 90. But it.
Trick question.
Yeah, I was. You can find the angles by using inverse trig. Or you could first find the missing side, the hypotenuse, by doing a squared plus b squared equals c squared.
Okay, we get it. Numbers.
Okay, any questions on this one? All right, I'll wait. What are you gonna write down?
I'm writing the equation that's on the line. You know, so I know what to say.
Gotcha. I gotcha.
All right, I'm ready.
Okay, have you guys done the second one yet?
Yes.
Man, I'll be like, can I move my head, bro?
Okay, so for the second one, negative 2x plus 1, y-intercept is at 1, down 2, right 1, up 2, left 1, up 2, left 1, solid line.
It should be over the top.
And because y's must be greater than this line, we need to shade above the line. Questions there? I know I'm going quicker. We got to get quick. Kind of like how I say we got to get quicker at solving an equation. You got to get quicker at graphing lines too. It should become pretty second nature to you. The second one, y must be greater than x plus 2. I'm here. The slope is 1. Up 1, right 1, up 1, right 1, down 1, left 1, down left, down left. This one should be a dashed line. And we're looking for y's greater than the line. So it'd be shading above this line. And so my solution, the point where the lines intersect, would be right here. Now, one thing I want to bring up, because I haven't really talked about it in a lot of detail. If the point is on this blue dashed line, is it part of the answer? No,
Because it's not equal to.
because it's dashed. If the point's on this red solid line, is it part of the answer?
Yes.
Yes. So my answer is everything I have in yellow and
The red line.
that red line. Right? Because that's the boundary. That boundary's inbound, where this boundary is out of bounds.
Yes. Let's get it.
Guess what we're going to do here?
Reverse.
Reverse.
Reverse. Reverse.
Slide to the left. No. Okay.
Slide to the right. Crisscross, everybody. I'm sorry.
So now I've got the graph, and I want to write what are the two inequalities that make up this graph. So I would start with the blue line. Why did I pick the blue line first?
Whatever.
Because I said so. It doesn't matter. It doesn't matter which one you pick first. I just picked the blue just cause. So, if I'm looking at the blue line, first let's let's write. I about said let's write the equation. my R did not come out with the word write. Let's write this equation for the line. So the blue line has a y-intercept of 4. Let me change my pen width back. It has a y-intercept of 4. And it has a slope of down 1, right 1, down 1, right 1. So the slope is -1.
Negative 1x.
And that would be -1x, which we could write it as -x or -1x. Doesn't matter. So the equation would be y equals this. Right? But we're not dealing with an equation. We're dealing with an inequality.
Greater than and equal to.
So it is going to have an equal to sign. How do I know it has an equal to sign?
Because it's a straight
Because
line.
it's solid.
Straight.
Solid line.
Scratch me, sound
Because it's solid, it has to be equal to. And now I would look at the y-intercepts. The shading of the blue is above this line. So I need y's to be greater than or equal to the line.
The straight line.
Any questions there about finding the equation for the blue line? Now for the red line. What's the y-intercept?
3.
Y-intercept is 3. And then what's the slope? So let's find another point of crosshair.
2, 1.
up to right 1. So the slope is 2 over 1.
2 and 1 x.
Don't say 2, 1.
Bruh.
2, 1 sounds like an ordered pair.
And it's not
2
fair.
over 1. So the slope would be 2 over 1 x plus 3. And remember, guys, this x is not part of the slope. The number in front of the x is the slope. Okay, so 2 is the slope. Should it be
Less
equal to
than.
sign?
It's less than. No.
Should it have an equal to sign?
It's number less than.
No. And less than because I'm shading below the line. So it would be less than. Y must be less than. And there we go.